Okay, all right. Even smaller than that. We don't need it that big. Yeah, that's fine. So H equals A plus BH plus C. Oh, there is no H. H equals B
CL
times CL, okay, plus C times what?
DME.
Mm-hmm. Yes. Plus,
That's it. I don't think there's anything.
because,
P, the D times P.
yes. And now, which one of these relationships are statistically significant?
They all are.
Okay, put a star next to each one of them.
Okay. Like this?
Yes. Okay, that takes care of H. Let's go
Okay.
and write the equation for LTH.
Let me just make this smaller. Okay, LTH.
Write it before H.
Oh, before H. Okay.
Yeah, this way we will always stay next to the image.
Equals.
Mm-hmm.
Let's say A plus. That would be. Oh, okay. I see. It would be. Can I use the same?
Yes, yes.
Okay, that's a star plus. I would say LTH is that plus P. So CP.
Yes. Plus what
Um,
else?
plus. This one's a good question because now we have arrows leading away from it.
Those things don't count. Only
Okay,
everything preceding.
preceding.
So
Okay.
DME and CL would also contribute
Exactly.
to LTH.
Yeah. So D times. Yeah. Plus.
So these
So
would not be significant?
exactly.
Ah, okay.
So what things are significant?
Direct causal if the
Ex-
arrow is going directly to it?
yes. Yes. Isn't that interesting?
Yes. Much easier when you explain it.
Yeah.
Yeah.
So so what this equation tells us is that uh, the
Mhm.
ones that are direct causes will become significant. The ones that are indirect causes will be there, but they will not be significant.
Okay.
And anything that follows the response variable is the variable on the left. Anything that follows the response variable is irrelevant, should not be part of the assignment. Okay, go ahead and write the next equation. Write the equation for RF.
RF would be equal to A plus, I see H and P as main ones.
Mm-hmm.
C, P plus. Okay, RF goes there, and then it goes H, and then CL, and then here I can just do like that. So RF will equal H, A plus H, B, I'm sorry, A plus BH,
Mm-hmm.
CP,
Mhm.
And then from, oh, but wait a minute, from H, yeah, that is correct. DME and CL. I think that's correct, yes.
Yeah. So, what's the name for things that are significant and right before? You said direct cause, but
Mm-hmm.
they are parents. The network name for them is parents in the Markov blanket. So, what is the Markov blanket of, let's say, H? What is the Markov blanket of H? It's the parents and the children and co-parents. So, what are the parents to H?
Parents to H is DME plus CL.
And also P.
Oh, and P, yeah, and P, yes.
And what are the children of H?
The children of H are uh, LTH, RF, SNF, and HOS. Oh, and BP.
Yes. And uh, what is a co-parent for H? For H, what is an example of a co-parent for H?
Co-parent.
So the parent of a child of H.
Parent of a child. Ah, okay, a parent of a child of H. Okay, so H, an H. Okay, so a child of H would be HOS, HOS, but
Mhm.
a co-parent would be LTH.
LTH is already a child, so can't be a
Oh,
co-parent.
can't be a co-parent. Oh, how about child of H is LTH, but a co-parent is P?
Exactly,
But
exactly.
isn't P already a parent of H?
Yes, so parent. But what about BP? BP is a child, and what is a co-parent that's neither parent or child of H?
That'd be PPD, right? PBD
Exactly, and what else?
and HHA.
Exactly, yeah. So that's a Markov blanket. Now, what's the Markov blanket is important, is perhaps one of the most important concepts in network structure, because if you change the Markov blanket, you you if you control the Markov blanket, nothing else is important. Now, inside regression,
Uh,
yes, go ahead.
I was gonna say, Dr. Alemi, you said the Markov blanket is the parent and the child. Does it also include the co-parent?
Yes, all three are part of the Markov blanket: parent, child, and co-parents. If you control these things, then nothing else in the network affects the node. So in this case, if we control all the parents, all the children, and all the co-parents of H, nothing else matters. So for example, here OT is a co-parent, but and in fact the entire network, PBD is a co-parent. Everything in the network is part of H, a part of. But let's look at the Markov blanket of OT. What's the Markov blanket of OT?
For OT, do the parents only, is that only considered LTHP, like those five that are right
Uh,
above it?
yes, those are the parents. What are the children?
The children would be BP, and that's it.
Right. And what are the co-parents?
HO, HOS. And well, yeah, that's it.
And H.
Oh,
H
yeah,
also.
yeah.
And what about DME? DME is not in the
It's
Markov blanket.
Yeah, it's a grandparent.
Yeah, DME is not in the Markov blanket. And what does that mean? If something is not in the Markov blanket and we control everything that's in the Markov blanket, what's the meaning of something that's not in the Markov blanket? Means that it's completely irrelevant.
Yeah, it's not going to have an effect
It's not going to affect OT.
Yeah.
Yeah.
So the Markov blanket for OT, would this be correct here? It would be 1, 2, 3, 4, 5, plus the child, which is BP, plus the co-parent of the child of BP, which would be HO, HOS, ONH.
Yeah.
And that would be it?
That would be it.
That would be the Markov blanket. Okay.
And what about DME, CL, and P? Those are all irrelevant.
Irrelevant. Mm-hmm. Yep.
Okay. So that's the network terminology. What is the same thing inside a regression? Inside a regression, anything that's significant is relevant, and anything that's not significant is irrelevant.
Mm-hmm.
And anything that's significant and preceding is the parent. Anything that's significant and following is the child. So we can identify parents and children by the timing of the events. And we can identify if they are inside or outside the Markov blanket by the by significance. So you wrote an equation for, let's say, LTH. In that equation, what is the parents of LTH?
Parents of LTH would be H and P.
So even if you didn't visually see the network, you would know that H and P are the parents of LTH. You see the equivalence? So this is called fidelity between the graph and the equations. The equation shows us what is the parent, and those are also in the graph as parents. You can see it in the graph very easily, but very often when you're analyzing large data, you can't see it. So you run a regression to see what is significant and preceding, therefore parents to the node.
Okay, I get it.
You get it?
Yes. So let's say you had some data with like 30 variables, and you ran a regression, and then of the 30 variables, 15 came back as significant. Those are all parents?
If they're all preceding.
If they're preceding. Okay, yes, that's key. Okay.
So if any of those that are significant are not, like, they come after, those would be the children then.
Exactly.